Namaste. I want to discuss trigonometry. Okay, now I am going to discuss this. In this, trigonometry. Trigono means triangle. Metry means measurement. So, triangle measurement. Triangle measurement. Tri means 3. So, now we are going to discuss this 3 angles measurements. About 3 angles. So, what are they? Sin theta, cos theta and tan theta. So, before going to this 3 angles, discussion about the 3 angles, so we need some basic concepts. So, I am discussing some basics. So, after that we will go to that trigonometric ratios and identities. So, in that basic concepts, the first one is line segment. Line segment. What is meant by the line segment? So, the name itself gives the fixed length, it has both end points. So, this is called line segment. It has fixed end points. So, this is called line segment. So, this is denoted by AB like this. So, the next one is ray. What is meant by ray? Ray. What is the definition of ray? So, in this line segment, if you extend this line segment to the infinite length, if you extend like this is called as ray. So, we are denoting this by like this arrow. So, this is, so 2 end points, so this is called the line segment, this is called the ray. Next, angle. What is meant by angle? What is meant by the angle? The union of the 2 rays. The union of the 2 rays having common end point is called the angle. Is called the angle. So, the union of the 2 rays, this is meant by the ray. So, if you take the 2 rays having common end point, this is called an angle. So, this is denoted by angle AOB. Okay, clear? Next, in the angle, there are so many angles are there. There are so many types, that is acute angle, right angle, next obtuse angle, next complementary angle, and supplementary angles. These are very important. So, the first one is acute angle. Acute angle means an angle less than 90 degrees is called acute angle. Right angle means, so 90 degrees is called the right angle. The symbol for this is like this. Next, obtuse angle means greater than 90 degrees. So, this is very important. Complementary angle means if the sum of the 2 angles is equal to 90 degrees, this is called the complementary angle. If the sum of the 2 angles is equal to 180 degrees, so this is called supplementary angle. So, these are the basic concepts of the angles. So, the next one is Here one more important concept, that is clockwise angle. Clockwise angle, anti-clockwise angle. So these are very, very important. So the clockwise angle, the meaning itself gives, we have to refer the clock. So the clockwise angle means, so see these two, this is called the initial ray and this is called terminal ray. So if the terminal ray moves like this direction is, that is the movement of the clock, the movement in the clock, the hands moves like this, the hands of the clock moves this direction. So that's why this is called as clockwise direction. And here one note point is, in trigonometry are this, the clockwise direction we are taking as negative, and the anti-clockwise direction means if the angle is, that is opposite to this one, this is the clockwise direction, the clock hands are moving like this, so this is called the clockwise direction. If the terminal ray moves like this, so this is called anti-clockwise direction. Here the important point is, we are treating the anti-clockwise direction as positive angle. This is very, very important. So clockwise angle and the anti-clockwise angle. So clockwise angle we are treating as negative and the anti-clockwise direction we are treating as positive. Next, the very, very important concept, Pythagorean theorem. Pythagorean theorem, this is very, very important. So this is discussed on right angle triangle. So take this right angle triangle, right angle is at B. So now the Pythagorean theorem says that hypotenuse square is equal to side square plus side square. So that is AC square is equal to AB square plus BC square. So here important one is, in right angle triangle, suppose this is 5 and this is 12, then what is the third side? Very, very important. How to find this third side? Means, so take this as x, and we know that from this side square is equal to, that is hypotenuse square equal to 5 square plus 12 square, that is x square equal to 144, that is 169, that is x equal to 13. So in this way we have to find the third side. So this is the Pythagorean theorem. The next basic concept is coordinate system. In this coordinate system, so briefly I will discuss about this coordinate system. This is geometry. Coordinate system. So in this, take the horizontal line as x-axis and the vertical line as y-axis. So these x-axis and y-axis divide this plane into 4 equal parts. We are calling this as quadrant 1, this is quadrant 2 and quadrant 3, and this is quadrant 4. Here in the first quadrant, the x coordinate and y coordinate both are positive, and in this, because y is negative, so that is y is negative, so this is minus and plus. In this third quadrant both are negative, in fourth quadrant So the positive and negative. So I have to remember this. So we are using this also in discussing about the trigonometric ratios. So in coordinate system, basically divide this plane into the 4 quadrants. In first quadrant both are positive, in second quadrant x is negative and y is positive, in third quadrant both x coordinate y coordinate both are negative, in fourth quadrant x is positive and y is negative. This is about the coordinate system. So these are the basics. So now I am going to discuss this trigonometric ratios. So very important. So what is meant by trigonometric ratios means the relation between angles and sides we are expressing in ratios. So we are calling that as trigonometric ratios. So we will discuss this in a right angle triangle. So that is A, B, C at right angle at B. So take this as theta. Now this BC is called as adjacent side. This AB is called opposite side. The line opposite to this is called hypotenuse. This is very important. Now for simplicity I am taking this as x and this as y and this as small r. Now the first angle sin theta. What is meant by sin theta? The definition of sin theta is opposite side by hypotenuse. So here what is the opposite side? AB by AC or y by x. So next what is the second angle? Cos theta. That is adjacent side by hypotenuse. That is here the adjacent side is BC. Hypotenuse is that is AC. That is here the hypotenuse is R. So here also R. So next tan theta. The third angle is tan theta. So this is opposite side by adjacent side. So that is opposite side is AB by adjacent side is BC. Here one more important thing is this opposite side by adjacent side. If you observe this is sin theta by cos theta. Sin theta by cos theta. Observe this opposite side by hypotenuse, adjacent side by hypotenuse. This hypotenuse gets cancelled. So opposite side by adjacent side. So this opposite side by adjacent gives, so that is sin theta by cos theta. This is very important. We can express tan theta also, sin theta by cos theta. These are the 3 angles. So trigonometry means triangle. So these are the basically 3 angles, that is sin theta, cos theta and tan theta. Now the reciprocals of this, that is the next one is cosecant theta. Cosecant theta is the reciprocal of sin theta, that is 1 by sin theta. So that is hypotenuse by opposite side, that is R by y. So similarly secant theta is 1 by cos theta. Secant theta is 1 by cos theta. So that is 1 by x by r. So this is r by x. So next the last one cot theta, that is the reciprocal of tan theta, that is 1 by tan theta. So that is 1 by tan theta means sin theta by cos theta, or opposite by adjacent, that is opposite is y by x. So this is x by y. So this is about the 6 angles. So sin theta, we have to remember this, sin theta is opposite by hypotenuse, cos theta is adjacent by hypotenuse, tan theta is opposite by adjacent. So these are the 6 angles. So we have to remember these formulae. So now I am giving some examples. So example 1. This is the right angle. Then what is cos theta and what is tan theta for this triangle? So very important. If this is theta, then what is cos theta? So we already discussed about this. What is cos theta? Cos theta formula is adjacent by hypotenuse. So here the important thing is, here theta is there. For this, the adjacent side is AB. Hypotenuse means a line which is opposite to the 90 degrees gives, that is AC. That is, this is cos theta. What is tan theta? So tan theta means opposite by adjacent, that is BC by. So theta, the opposite side is BC and adjacent is AB. So this is one good example. Next, example 2. If sin theta is equal to 5 by 13, then tan theta. If sin theta is equal to 5 by 13, then what is tan theta? So how to find? We have to draw the right angle triangle. So this is theta, opposite by hypotenuse. So this is 5 and this is 13. So obviously, if you don't know this, then take this as x and this is square equal to hypotenuse square equal to side square plus side square we have to write. So obviously this is 12. So from this, what we have to find? Tan theta. What is the formula for tan theta? Opposite by adjacent, that is 5 by 12. Next, example 3. If tan theta is equal to, if tan theta equal to root 3, then sin theta equal to. So how to find this? So we have to draw the right angle triangle. So tan theta root 3 means, that is root 3 opposite by adjacent. Then what is hypotenuse? How to find the hypotenuse? We already discussed this. Take this as x. X square equal to root 3 whole square plus 1 square. That is x square equal to 4. So x equal to 2. So this hypotenuse value is 2. Then we have to find sin theta. What is the formula for sin theta? Opposite by hypotenuse. So that is root 3 by 2. So these are the best examples. So next I am going to discuss the values of all trigonometric ratios, that is 0, 30, 45, 60, 90. Sin theta, cos theta, tan theta, so this very important table, we have to learn this also, we have to by heart this also, we have to remember this. So what is sine 0, what is sine 30, what is sine 45, what is sine 60 and what is sine 90. So one interesting way I am discussing here, see this, here I am discussing. So put our hand like this is 0 degrees, this is 30 degrees, this is 45 degrees, this is 60 degrees, this is 90 degrees. So for finding sine theta, the formula is root of below side fingers by 2. So by using this we can simply remember this. So sine theta, so that is below side fingers by 2, root of below side fingers by 2 gives sine theta. So first of all, how to find sine 0 means, so put like this, below there are no fingers, that is 0 by 2, that is 0. So for sine 30, for sine 30, put the finger like this. So below how many fingers? One finger, that is root of 1 by 2, that is 1 by 2. So the next one is 45. So sine 45. So below how many fingers? 2 fingers, that is root of 2 by 2, that is 1 by root 2. So the next sine 60. So keep this finger like this, below how many? So sine 60, below how many? So that is root 3. So we have to put root of, below fingers are 3, that is root 3 by 2. Next the last one, sine 90. So keep this. So below this there are 4, that is root 4 by 2, that is root 4 is 2 by 2 is 1. So in this way, so first time we can derive like this. After that we have to remember sine 0 is 0, sine 30 is 1 by 2, sine 45 is 1 by root 2, sine 60 is root 3 by 2, sine 90 is 1. So similar way we can derive the cos also. So for cos, so the same way we have to put, that is cos theta is above fingers by 2. So clear about the sine theta? So once again I am explaining. So I have to put like this. So below finger for this is no, so that's why 0 by 2. For 30 below finger is 1, root 1 by 2. So for 45 below fingers is 2, so root 2 by 2. Below fingers is 3, so root 3 by 2. Below fingers is 4, so root 4. So similarly for cos also. So for cos the formula is cos 0. Cos 0. So put the same, but here we have to put this finger like this. So here above fingers, upside fingers. So upside fingers are how many? 4. Root 4 by 2, that is 2 by 2. So cos 0 is 1. So similarly, next put 30 like this. So how many fingers are there above that? 3. That is root 3 by. So cos 30 degrees, that is root 3 by 2. Next cos 45 degrees. What is cos 45? Above fingers are 2, that is root 2 by 2, that is 1 by root 2. So that is next cos 60. So above cos 60, how many are there? 1, that is root 1 by 2, that is 1 by 2. The last one cos 90. Cos 90. So if you put like this is 0, 0 by 2, that is 0. Okay, clear? So very simple. So first time you have to do like this. After that you have to cos 0 is 1, cos 30 is root 3 by 2, cos 45 is 1 by root 2, cos 60 is 1 by 2, cos 90 is 0. Okay. So in the other way also we can remember this, observe this. sin 0 0, sin 30 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 91. So if you observe this in this way, 0 1 by 2, 1 by root 2, root 3 by 2 1. Now observe this. So this 1 is here, root 3 by 2 here, 1 by root 2 is here, 1 by 2 is here, 0 is here. That means simply you have to reverse this also, we'll get this cos also. Next, tan. Tan means we already discussed sin by cos gives tan. So that is 0 by 1 is 0 by anything 0. So 1 by 2 by root 3 by 2, that is 2 gets cancelled, 1 by root 3. So 1 by root 2 by 1 by root 2 same, so we'll get 1, and 60 root 3 by 2 by 1 by 2, 2 gets cancelled, that is root 3. So 90, 1 by 0 not in the denominator, if you have the 0 that is not defined, or we can write infinity also, no problem. So this is about the angles 0, 30, 45, 60, 90. So we have to totally remember this. Sin 0 is 0, sin 30 is 1 by 2, sin 45 1 by root 2, sin 60 root 3 by 2, sin 91. Similar way, cos 0, cos 30, cos 45, cos 60, cos 90, you have to remember this total table. So by using this way, okay, clear? So this is the table, sin, cos, tan. By using this, we can remember this table. This is very, very important. The next one, quadrant signs of trigonometric ratios. Okay. So the quadrant signs of trigonometric ratios. So in this, first of all, take a circle, then take the horizontal line and vertical line, take a point px, come over here, draw like this. This is x, and this is y, and this is r, this is theta. Now we already discussed this. That is, what is sin theta? Sin theta is opposite by hypotenuse. What is cos theta? Adjacent by hypotenuse. What is tan theta? Sin theta by cos theta. That is y by r by x by r, that is y by x. What is cosec theta? That is r by y. That is the reciprocal of sin theta. What is secant theta? The reciprocal of this, that is r by x. What is cot theta? The reciprocal of this tan theta, that is x by y. So here the important point is, in the first quadrant, so which trigonometric ratios are positive? I had to discuss this, and to remember this we have a table also. So before going to the table, so I am discussing, observe this, in the first quadrant I already discussed, all are positive, x and y both are positive. So these are all are positive. So the first, in this, all trigonometric ratios are positive. All trigonometric ratios are positive. So come to the second quadrant. In the second quadrant, x is negative. So x is negative means in this sign there is no x, and in the cosecant also there is no x. Observe this, in the remaining all these x is there. So in the second quadrant, so only y is positive. So y r both are positive, the sine and cosecant. So sin theta and the reciprocal of sine, that is cosec theta, these two are positive. So come to the third quadrant. If you observe the third quadrant, we already discussed in this, both x and y both are negative. Both are negative. So x and y both are negative. So observe this tan theta. This is negative by negative. gives what? Positive. So this is, so if 1 is negative, suppose if you take sine theta, y is negative means this sine is negative, x is negative means both x and y both are negative, so cos is negative, but tan negative by negative is positive. So in third quadrant the tan is positive, the reciprocal of tan is cot, here also negative by negative positive, so these two automatically we know x and y negative, so these two are negative. So in this the tan theta and the reciprocal of tan is cot is positive, these two are positive. So come to the fourth quadrant. In the fourth quadrant x is positive, y is negative. So x is positive, y is negative. So x is positive, x is there in cos theta, and so the reciprocal of cos theta is secant theta. So if you observe this tan theta, here is also x is there, but y is positive, so x is positive, y is negative. So here cos theta and the reciprocal of cos is secant theta. So these two are positive. So how to remember this means all silver tea cups. By using this we can easily remember that all means all trigonometric ratios are positive in the Q1. In Q2 only silver, all silver. Silver means starting with sine, that is sine, and the reciprocal of this is cosecant. These two are positive. And in the third one, T means starting with the T, that is tan and cot. In Q3, tan and cot, these are positive, that is cups in cos and secant. In Q4, the cos and secant, these are positive. So I have to remember like this, all silver tea cups. So no need of this discussion. So simply for understanding purpose I explained. So what we have to remember is all silver tea cups. In the first quadrant all, second quadrant silver. Silver means sine and cosecant. So in third quadrant T means tan and the reciprocal of tan is cot. In this these two positive. Cups means cos and secant. So we have to remember this. This is very very important. So this is the quadrant signs in trigonometric ratios. By using this all silver tea cups, we can easily remember this. In which quadrant which trigonometric ratio is positive, we can remember by using all silver tea cups. The next one, identities. So the first identity is prove that sine square theta plus cos square theta is equal to 1. So how to prove this? That is sine square theta plus cos square theta. This is very very important one. So where theta is the parameter. So now what is sine theta from this diagram? Y by r. What is cos theta? So see here, what is cos theta? X by r. Now what is sine square theta? Y square by r square. What is cos square theta? X square by r square. Now LHS part I am taking sine square theta plus cos square theta. So this is equal to y square by r square, x square by r square. So what is the LCM? R square. So this is x square plus y square. So in this right angle triangle we know that from Pythagorean theorem, so side square, that is side square plus side square equal to hypotenuse square. This is Pythagorean theorem. So we can replace x square plus y square by r square, that is r square by r square is 1. So this is very very important. Sin square theta plus cos square theta equal to 1. From this we can write this also. Sin square theta equal to 1 minus cos square theta, or cos square theta equal to 1 minus sin square theta. So we have to remember this. This is the first one. The next identity is prove that 1 plus tan square theta equal to secant square theta. This is the second identity. So similarly from here, what is tan theta? What is tan theta? So that is y by x. What is secant theta? R by x. Now take LHS part, 1 plus tan square theta. So this is equal to 1 plus tan square theta is y square by x square. So by taking LCM, x square, so this is x square plus y square. So from this x square plus y square equal to r square. So this is r square by x square. So now what is RHS part? Secant square theta. So this is equal to, what is secant theta? R by x. So this is r square by x square. So observe this LHS is equal to RHS. So therefore 1 plus tan square theta equal to secant square theta. 1 plus tan square theta equal to secant square theta. So see here the next identity, 1 plus tan square theta equal to secant square theta. From this, secant square theta minus tan square theta equal to 1. So we can again write this one as secant theta plus, these are the applications for this. We can write secant theta a square minus b square. We can write this one as a plus b into a minus b. So secant theta plus tan theta into secant theta minus tan theta is equal to 1. So from this we can write secant theta plus tan theta is equal to 1 by secant theta minus tan theta. So here very important example is that if secant theta minus tan theta equal to 2 by 3, then secant theta plus tan theta is what? So from this we can say these two are reciprocals to each other. So product gives 1. So secant theta minus tan theta is 1. So secant theta minus tan theta, or we want to find this secant theta plus tan theta is nothing but 1 by secant theta minus tan theta, that is 1 by 2 by 3, that is 3. If secant theta, example 2, if secant theta plus tan theta equal to b, then secant theta minus tan theta is what? So similarly, because these two are the reciprocals to each other, if this is b, then secant theta minus tan theta, we can write this one as 1 by secant theta plus tan theta. So that is 1 by p is the answer. So this is the second identity. The first identity is sin square theta plus cos square theta equal to 1. The second one is secant square theta minus tan square theta equal to 1. The third one is cosecant square theta minus cot square theta equal to 1. So we can prove that third identity also. Prove that cosecant square theta is equal to 1 plus cot square theta. Now take RHS 1 plus cot square theta. This is 1 plus, what is cot? X by y, that is x by y whole square, that is 1 plus x square by y square, that is y square plus x square by y square. From this right angle triangle property, hypotenuse square equal to, that is x square plus y square, is r square by y square. So now see LHS, cosecant square theta is, what is cosecant theta? R by y whole square, that is r square by y square. Now see these two, this RHS part is r square by y square, LHS part is r square by y square, therefore LHS is equal to RHS. So this is the third identity. So we have to remember these three identities. So that is sin square theta plus cos square theta equal to 1, secant square theta minus tan square theta equal to 1, cosecant square theta minus cot square theta. So the next one is prove that tan theta into cot theta equal to 1. Prove that secant theta plus tan theta equal to 1 by secant theta minus tan theta. Next, third one, prove that cosec theta plus cot theta equal to 1 by cosec theta minus cot theta. So here we already know that tan and cot both are reciprocals to each other. So take this LHS, that is tan theta into cot theta. So that is tan theta into cot theta, we can write this one as 1 by tan theta. So these two gets cancelled. So this is 1. So tan theta into cot theta, because these two we already know these two are reciprocals to each other. So this is the way. So prove that secant square theta, secant theta plus tan theta is like this, means we already derived this, that is secant square theta minus tan square theta equal to 1. This is we know. Secant square theta minus tan square theta equal to 1. And we know that we can write a square minus b square as a minus b into a plus b. A minus b into a plus b. So similarly we can write this one as secant theta plus tan theta into, we can write secant theta minus tan theta, because this is the product we can write no problem, because commutative property, this is 1. So from this we want secant theta plus tan theta. So this is 1 by secant theta minus tan theta. This is the proof. Okay. In the similar way, third one also, a result we know that we already proved. We know cosecant square theta minus cot square theta equal to 1. That is cosec theta plus cot theta into cosec theta minus cot theta equal to 1. So from this cosec theta plus cot theta is equal to 1 by cosec theta minus cot theta. Okay, so once again I am discussing, we are recalling this formula. ಅದನ್ನು sin theta, cos theta, these are the three angles. So take a right angle triangle. So this is y, this is x, and this is r. So what is the formula for sin theta? So that is opposite by hypotenuse. For cos theta, adjacent by hypotenuse. For tan theta, we can remember like this also, sin theta by cos theta, that is y by r by x by r, this is y by x. In the similar way, we have to remember the table also. What is sin 30? How to write the sin 30 value? So I am giving one simple technique, that is, so put the hand like this, that is 0, 30, 60, sorry 45, 60, 90. So that is for sin theta we have to apply this, that is root of below side fingers by 2. That is, now we want to find sin 30. For sin 30, root of sin 30 means we have to put this finger like this, the below finger is 1, that is 1 by 2. So that is sin 30 is 1 by 2. So we have to remember like this. So what is sin 60? How to put means, so put sin 60 here. So put the fingers like this. So keep this finger like this. So the below fingers are 2. So that is root of 2 by sin 60, sorry, 3. So that is, so if you put like this, these are the 3. So if you put this 60 like this, that is root 3 by 2. So in this way, so sin 60 is root 3 by 2. So similarly, so sin 30 is 1 by 2, have to remember, sin 60 is root 3. So for cos also, how to remember this cos? Cos means root of above fingers by 2 gives. So how to find cos 45 and cos 60? So cos 45 means, so put like this. So cos 45, so put this finger like this. So above there are 2, so that is root of 2 by 2, that is 1 by root. So cos 60 means put this finger like this. So the above, that is 1 by 2, root 1 is 1 by 2. So in this way we can calculate this. So table also I am giving once again. I have to remember this 0, 30, 45, 60, 90. For sin theta, sin 0, 0, I have to remember this by heart, this sin 45, 1 by root 2, sin 60, root 3 by 2, sin 90, 1. If you remember this, we can write cos theta by using this fingertips, or we can rewrite this reverse way, that is 1 root 3 by 2, 1 by root 2, 1 by 2, 0. So if you remember these two, then we can write easily tan theta, that is tan theta is, so sin by cos 0 by 1 is 0, so this is 1 by root 3, so this is 1, this is root 3, this is not defined, or we can write infinity also. Okay, this is the table. So these are the basic concepts in trigonometry, and the basic identities are sin square theta plus cos square theta equal to 1, and secant square theta minus tan square theta equal to 1, and cosecant square theta minus cot square theta equal to 1. Okay, thank you.